So we're going to start by going over the review sheet from Friday. I'm not going to spend a huge amount of time on this because you had the entire period on Friday to do it. What are the 4 factors that affect climate? We just learned these. Latitude, elevation, nearness to a body of water, and ocean currents. How does latitude affect climate? What I needed you to know is the closer to the equator, it's warmer. Closer to poles, colder. And then the one that you know but haven't thought of, as latitude increases, temperature range increases. Meaning as you get closer to the poles, the difference between the warmest day and the coldest day, the difference gets bigger. What effect does nearness to a large body of water have on a location's temperature range? Again, temperature range. When you get closer to a body of water, you have warmer summers, you have cooler summers, warmer winters. So the range actually decreases. Locations near a large body of water have warmer winters and cooler summers. So the lake actually keeps us slightly warmer in the winter. And how this works is when you have a 32-degree lake or anything above 32, so it's not frozen. In the middle of winter, if you have a 32 degrees breeze blowing off the lake, that's going to feel slightly warmer for you than whatever, like the 25 degrees that you would have been otherwise. So during the winter, it blows slightly warmer air on us. And then during the summer, the lake will cool you down a little bit because again, the lake's not as hot as the land. So the lake's always a little bit cooler in the summer. So if you're next to the lake, you'll feel a cool breeze in the summer. And because we have warmer winters, cooler summer, that gives us a smaller range. These ones you had to look up right in your reference table. And because I didn't do an answer key yet, the East Australian Current, that EAC from Finding Nemo. The EAC, that is a black arrow. So you bring that down to the key, that is a warm current. The North Equatorial Current, I have to find that, I guess. The North Equatorial Current, it's in several locations. All of them, again, the black arrow, which is a warm current. And finally, the Peru Current right here. The Peru Current is a black arrow, and those represent a cool ocean current. Told you could skip these two boxes for now. And then you just needed the definition of each. Evaporation is when we go from liquid water, so H2O, to water vapor. Transpiration is water entering the atmosphere from plants. Runoff is water that does not soak in. Water that does not soak into the ground and flows over land. Infiltration is water soaking in. Condensation, that is gas water going to liquid water. Precipitation is water falling from clouds. Permeability, ability to soak in, or ability of water to go through a material. And permeability rate, again, it's how fast water goes through. Porosity is not the number or the size, it's the amount of holes, or hole space, I should say. How does size affect permeability? What do we know? This is something you need to know off the top of your head. How can you fill that in? Okay. Larger particles allow water to go through faster. Larger, faster. How does size affect porosity? It just does not. 5 conditions that will cause an increase in runoff. If we want the water to run off, what should the ground be like? Okay, one thing could be frozen. Another one. Yep, so steep slope. Impermeable. Steep slope, frozen, impermeable. That's the frozen. How about, yeah, rain, and then the other one is raining faster than thank you. Raining faster than infiltration, and the last one is the ground is already saturated. Highest infiltration rate. What do we want the soil to be like for the water to soak in? We already talked about one. Larger particles. What's another one? Loosely packed. What else? Sorted soil. And what shape? Round or angular, guys? Rounded. Highest capillary action. Small particles. Which process in the water cycle can raise the water table? What's going to cause the water table to go up? Precipitation. And what will cause it to go down? Evaporation. And also technically transpiration. And finally, if the soil has a high permeability, that means water. Where's the water? What's the water doing if we have a high permeability? Water can go through. So if water can go through, how much runoff will we have? Not much. Runoff will be lower. And if soil has a low permeability, that means the water cannot go in. So since it's not going in, what's happening? Runoff will be higher. So if it's not going in, then we'll have lots of runoff. So that was what you should have been able to complete on Friday. Hopefully you have a good review sheet. We will finish these two tomorrow. I would assume you're going to have a test by Thursday or Friday. I'll know more by the end of tomorrow. Grab your homework pages 10 through 12. I want to go over those as well. So again, I'm just going to go kind of fast because we only have 5 minutes. Which change would likely result from replanting field B? That would be the water infiltration would increase. They would have a higher permeability rate if there were larger rocks. Soils in New York State, remember, they've all been transported by glaciers. That was a review from Weathering and Erosion. Everything in New York State has to do with glaciers. Which one will, I never really talked about the development of soil. Guys, do you know what soil is? Soil outside that you put in a garden. It's, okay, so is it just dirt? Okay, there's stones. What else is in soil that's not just in dirt? Worms. I couldn't hear what you said. There is, but I'm getting at, like, stop thinking earth science. What's in the dirt? Yes, there's worms. What else is in the dirt? Bugs, roots, decomposed leaves, living things. Which one of these, the one with the grass or the one without the grass, will have more soil developing? With the grass. So field A, because plants are adding organic material. All right, and if those skies remain clear for the week following, the water in the wet zone, so the wet zone, what will happen to it in field B? Yeah, it will partially evaporate into the air. Assuming constant land slope, the greatest infiltration rate, remember we need it to soak in, so we need it to be permeable and unsaturated. Answer 3. Which soil will allow the least amount of water to infiltrate? The least amount, which one? Granite, because it has no holes. Which type of soil will water infiltrate most slowly? Remember, clay is the smallest out of any, so it'll go in slow. We decrease from 10 to 5 degrees Celsius. What's happening in between 10 and -5? Well, what's happening to the 10? Like why are those numbers important? The ground is doing what? It's freezing. So the infiltration rate will go down because it can't soak in anymore. Flash flooding occurs in a city because roads, pavement, and buildings reduce the ability to infiltrate into the ground. Answer 3. Which is the deepest zone water can be pulled into? Anything that's not impermeable. So saturated is the deepest zone. Transpiration, remember, is coming from plants. So that's number 1. Clouds have formed primarily because, remember, air rises, expands, and cools to its dew point. That's answer number 1. And for infiltration to occur, we want the ground to be permeable and not saturated. Wind blowing the clouds, remember, wind blows from high to low pressure. That's answer 2. And which would occur So a list of these, we've got erosion equals deposition, insulation equals radiation, and condensation equals evaporation. That is called equilibrium. When everything is equal, that is equilibrium. If you have any questions on homework on pages 10 through 12, please bring those with you tomorrow. No homework today.